Hello, ladies and gentlemen, and welcome to the first video for pre-cal, and it's transforming trig equations. Ladies and gentlemen, we're going to be graphing some trig graphs, and in order to do so, I'd like to show you what could happen to a trig graph if you just change one number. So I want you to let f of x be a trig function like sine of x, cosine of x, or really any of them. If that's the case, we're going to let f of x be, and actually, you know what, I was just thinking about it right now. This should be y equals a times, a times f of b of x minus c plus d. So if you wouldn't mind, do me a favor, go ahead and write that down. This equation, y equals a times f at b times x minus c plus d. Please put all the parentheses there. They're all necessary. I will explain to you what each of them do, and then I'm going to show you graphically what each of these do. For instance, D. D is the vertical shift. It moves the graph up and down. And by the way, please put this on page, I want to say page 23. This should be on page 23, and go ahead and title it Transforming Trig Equations. So I'm going to put it right here. Page 23. All right, Transforming Trig Equations. Make sure you update your table of contents as well. All right, ladies and gentlemen, D is the vertical shift. It moves the graph up and down. So what does that mean? Well, check this out. Ladies and gentlemen, I have drawn the graph of cosine here. And notice that cosine doesn't have any numbers added to it. So what I'm going to do is I'm going to go to our menu. Oops, sorry. Forgot I have to put the pointer on. So what I'm going to do is I'm going to go to our menu here, and I'm going to add a graph entry, a function. And this time, instead of putting just cosine, I'm going to put cosine of x. But this time, I'm going to add, let's add 1. I'm going to add 1. What this is going to do, and you'll see it'll be right there, it's going to shift the graph up 1 unit. So if I do plus 1 for the d value, then it's going to shift the graph 1 unit up, just like this. Well, guess what happens if I subtract something from that cosine? Well, we'll find out right now. When I write cosine of x, this time I'm going to subtract 1. And look at that. It shifts the graph down 1 unit. Now, the blue graph is the original cosine graph, and the red one is when we shift it up 1 unit, and the black one is when we shifted it down 1 unit. Okay, now this could happen. I could shift it up 5 units. I could shift it up 10 units. But all it does is move the graph up and down. All right, so now let me go ahead and delete this one. I'll go ahead and delete this one. Oops. You know what? Never mind. I'm not going to delete it. I'm going to keep it there. What I'm going to do is I'll just go to another graph. So let's go to another graph. Documents. Insert new graphs. All right. Yay. So now what I'm going to do is I need to reset my window. Sorry about that. I forgot. Every time you do this, you have to reset the window. So let me go to window. And oops. So my other window was on the X was negative 1.57, and this one I believe was I just made it 3. No, it's 7. And auto scale this y value, I'm going to make it negative 3, and this will be positive 3. Positive 3. And hit OK. Alright, this time, ladies and gentlemen, on this new graph, I am going to graph the sine of x. Just because I want to try something different. Just to show you. And I'm going to go back to the notes. C. This time we're going to look at C. C is a horizontal shift. It's inside the parentheses next to the x. It shifts the graph left and right. Okay? Left and right. So, here's what I'm going to do. I'm going to go to our graph. Okay? And this time I'm going to subtract. This time I'm going to subtract. I keep forgetting to put that pointer. Alright, so I'm going to subtract, and I want to subtract 1.57. Okay, I'm going to subtract 1.5. Well, first let me draw a graph of the sine. That's what sine looks like. Okay, now what I'm going to do is I'm going to add a graph. This time, the graph I'm going to do, I am going to take sine of x, and I'm going to shift it to the right 1.57. And look at what this looks like. It takes all the points and shifts the graph over to the right. Say, well, Mr. Martinez, you subtracted. Why did it go to the right? Anytime it's inside parentheses like this, you do the opposite. Okay, and we learned that in Algebra 2. All right, let's add another graph where we shift it to the left. And if you guessed right if you said, oh, shifting to the left, you're going to add. Yeah, I'm going to add. So sine of x plus 1.57. And I'll explain why I'm picking 1.57 on this, but for right now, just take me for my word. Here we go. And there we have it. We shifted the graph back. And there's the orange graph right there. Looks kind of cool when you have all the waves together like that. But the pink graph is the original graph. It's not shifted over at all. The green graph is shifted to the right 1.57 units. And the orange graph is shifted to the left 1.57 units. You know, I do want you to draw these graphs. And so you could rewind the video and pause it so that you can draw some really nice graphs. And notice that they do cross at certain places. Okay, they do cross at certain places. So you want to make sure that you kind of capture where they're crossing. Okay, and then don't forget to write the equations. Feel free to go back to the cosine where we shifted it up and down and write these graphs along with their... And it'd be nice if you did it in color, but if you just do it in black and white or pencil, it's fine. It's not a big deal. This is for your notes. How do you shift graphs up? How do you shift graphs to the right and to the left? Okay. All right, let's go back to the notes. Now we're going to talk about a phase shift. Now, phase shifts are kind of cool because this will tell you how many times the graph is going to repeat itself between 0 and 360. Okay, so please don't forget to write these notes as well as drawing the graphs that we're doing. And you're going to put this on page 23. You might have to go to 25 because there's a lot of graphs, lots of notes. So let's go ahead and do this b. You'll see that b is being multiplied by the x on the inside of parentheses, okay? So let's go ahead and let's go look at that real quick. And I need to, sorry. I just opened something up I shouldn't have opened up. Alright, not a problem. I'll just close it. Alright, and close that too. Alright, so let me go ahead and open a new graph. doc. No, not doc. Menu. New function. No, doc. Insert. Browse. Alright, there we go. Now, ladies, I'm going to go back to cosine. So, we're going to do cosine of regular x. Okay, and this looks like cosine. You've seen this before. Notice I didn't change the window. I need to go back and change the window. I got to remember to do that every time I do this. So let's go to window. And notice I'm doing my window at negative 1.57. I will let you know what that number is later. And this is going to be 7. This one's going to be negative 3. And I'm going to go to negative, I'm positive 3 on the y. So there we go. Go ahead and draw this. This is going to be our cosine. But now, inside the parentheses, I'm going to multiply something here. Okay, I'm going to multiply by something. So, this graph, if you look at it, starts here, it goes down, and it goes back up to this same point up here like this before it gets to 360 degrees or 2 pi. What I'm going to do is I'm going to make this thing repeat itself 2 times before it gets here. So notice the brown graph just repeats once. It goes down and back up. Now check this out. By simply putting a 2 in front of that x, watch what happens to the graph. It goes down, up, repeats once, goes down and up, and it repeats 2 times before it gets here. So this graph has a phase shift of 2, okay? Phase shift of 2. It repeats itself twice, all right? I can make it repeat itself more times. Check this out. I'll just do a ridiculous one. I'm going to make it repeat itself, oh, I don't know, 8 times. So 8 times. Bam. Look at that. The red graph repeats itself 8 times. It goes once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. This has a phase shift of 8. Okay? A frequency. And we'll talk about frequency and period and all that, but just trust me, we're just learning what these numbers on the inside and the outside do. Some of you might be asking, hey, sir, what happens if we change these graphs? So what I'm going to do is let me get rid of this one right quick. I'll just get rid of that one real quick. Oh, I forget. I can just press the check mark. And then let me go up one. Let me just take that check mark off. Here's the regular graph. It repeats itself 1 time. I could actually put a fraction in there. So let's go. I'm going to go down to the red graph. And instead of putting 0.8, I'm going to put 0.5. This is half. It's going to repeat itself half time. So in other words, instead of going down and then back up, it's just going to go down and it's not going to come back up. Check it out. Okay, where'd it go? Oh, you got to put the check mark. Hello. Bam. So look at that. See how it goes down and then it just stays down the bottom and doesn't come back up yet. So this has a 0.5 phase shift. Okay? 0.5. It only repeats itself half of the time. Okay, and you can make it repeat itself 3/4 of the time, half of the time, quarter of the time, just depending on what you want to do. All right? All right. So now, ladies and gentlemen, we've looked at vertical shifts, horizontal shifts. We've changed the phase, or the amount of times it repeats itself. The next one, ladies and gentlemen, is this thing called amplitude. This is a stretch of the graph vertically. So I'm going to go here, and I'm going to put, let me put the pointer on. Let's go to document. I'm going to insert a graphs. Okay, and this time I'm gonna use this. I'm gonna go back to sine of x. Oops, I'm gonna go to sine of x. Gotta put the parentheses. I forget. And it's gonna draw the sine of x, but I'm gonna change the window. So I'm gonna go to the window, and I'm going to set the window at negative 1.57 to 7. And this is going to be negative 3, and then next one's going to be positive 3. Okay, and I'm going to ask it to graph it. Alright, so it's a regular sine graph. Starts at 0, goes up, comes back down, goes to 0 again. Alright, but now what I'm going to do, ladies and gentlemen, that's the regular one. I'm going to go ahead and in front of the sign, I'm going to put a number like 3. Okay? And I want you to notice what that's going to do to the graph of sine. I'm not putting anything else. This graph only went up a little bit. Now this graph goes up 3 times as high. Okay? It goes up to 1, and then this one goes up to 3. But notice that it repeats itself exactly the same way the black graph does. It goes down and up. Okay, so now let's try another one. And I'll just put in a different value. You can actually put in decimal values if you want to. I'm gonna put let's do 2.25, 2.25 sine of x. When I do this, it'll draw this green graph, and this green graph, ladies and gentlemen, notice it's between the original graph and it's between the top graph of 3. So, and that's the amplitude. It messes with the amplitude. Amplitude is also a way that your headphones increase the sound waves in your headphones. So actually it's happening. You're making the sound waves taller, and it makes the sound louder. We could talk about that later on, and you might even talk about it in physics. All right. Other than that, ladies and gentlemen, these notes that I've given you, and hopefully you're writing them down, these are what all these things do. I may put on a test or quiz. Hey, I want you to change the amplitude from 3 to 5 and draw the graph. I want you to change the vertical shift from 8 to negative 6. Show me what that does. All right. So take these notes and come to class ready to do some graphing. We will do all our graphing mostly on the graphing calculator. Thank you for watching. Don't forget to subscribe to my channel so that you can be notified the next time I post a video for pre-cal.